The James Webb Space Telescope has captured the clearest image yet of Proxima B, unveiling breathtaking details about this intriguing exoplanet, located just 4.2 light-years away in the habitable zone of its parent star, Proxima Centauri. This rocky world has long captivated astronomers and the public alike, hailed as a potential second Earth due to its size, location, and intriguing conditions. Often referred to as Earth's cousin, Proxima B raises thrilling questions about whether it could host oceans or even life. The discovery and now detailed observation has deepened interest in the Proxima Centauri system, which also includes another known planet, Proxima Centauri C, and potentially more undiscovered companions that may hold secrets of their own. Among the thousands of known exoplanets, Proxima B stands out for its relative proximity to Earth and its location in a habitable zone where temperatures could allow liquid water to exist. One of the planet's more peculiar traits is its extremely short orbital period, just 11.2 Earth days, meaning it orbits much closer to its host star than Earth does to the Sun. This proximity likely results in tidal locking, a condition where one hemisphere of the planet is in perpetual daylight while the other remains cloaked in eternal darkness. Such a stark dichotomy between the two sides of the planet poses significant challenges for habitability. Yet the tantalizing potential for water, an essential ingredient for life as we know it, remains one of the planet's most compelling mysteries. Proxima Centauri, the red dwarf star at the heart of the system, is a part of the Alpha Centauri triple star system, which also includes Alpha Centauri A and B. Despite being the closest star to our own solar system, Proxima Centauri is invisible to the naked eye due to its faint magnitude. Red dwarfs like Proxima Centauri are fascinating astrophysical objects, efficient, cool, and remarkably long-lived, capable of burning for trillions of years. The stellar longevity theoretically provides a stable environment for orbiting planets to develop life over extensive time scales. However, red dwarfs are also known for their intense stellar flare activity. As a flare star, Proxima Centauri frequently emits bursts of radiation that can dramatically affect nearby planets. These flares may strip away a planet's atmosphere or expose its surface to harmful radiation, potentially rendering otherwise habitable worlds hostile to life. Proxima B, which orbits its star at a mere 0.05 astronomical units, the flares pose a significant threat to its atmospheric stability and, by extension, its potential for life. The James Webb Space Telescope, equipped with cutting-edge infrared instruments, is ideally suited for probing the atmospheres of exoplanets like Proxima B. By detecting the infrared light emitted or reflected by the planet, astronomers can analyze its atmospheric composition, searching for indicators such as water vapor, carbon dioxide, methane, or other greenhouse gases that might hint at habitability. Yet, even if an atmosphere is present, that alone does not guarantee a hospitable environment. Proxima B could resemble Venus, where a thick atmosphere traps heat and creates scorching surface temperatures. These nuances highlight the complexities involved in evaluating the true nature of distant worlds. Still, Proxima B remains a top candidate for study because its relative proximity allows for more detailed observations than almost any other known exoplanet. The challenges in unlocking Proxima B's secrets are formidable. Despite its cosmic closeness, our current propulsion technologies are insufficient for direct missions. Sending a spacecraft to Proxima Centauri with existing propulsion methods like those used in the Voyager missions would take tens of thousands of years. However, ambitious proposals such as solar sails, ultralight spacecraft, propelled by radiation pressure from the sun or lasers offer hope for future interstellar exploration. Concepts like Breakthrough Starshot propose deploying tiny high-speed probes that could reach Proxima B in just a few decades, returning valuable data and images. While still in the conceptual phase, these technologies are not outside the realm of possibility, and their development could mark a historic leap forward in human space exploration. Proxima B therefore serves not only as a subject of scientific inquiry, but also as a beacon of what might be achievable in the near future. The planet's discovery has reinvigorated humanity's fascination with the cosmos and has fueled the quest to understand our place within it. As the closest known exoplanet to Earth located in a habitable zone, Proxima B is uniquely positioned to serve as a natural laboratory for studying the conditions necessary for life. Yet with every answer we uncover, more questions arise. The very nature of Proxima B challenges our understanding of planetary science, habitability, and the resilience of life in extreme conditions. For example, the intense magnetic activity of its parent star could strip away Proxima B's atmosphere or prevent its formation altogether. A planetary magnetic field, like Earth's, which protects our atmosphere from solar wind, would be critical in preserving any semblance of habitability. However, the extreme activity from Proxima Centauri could overwhelm even a strong planetary magnetic field, further complicating the prospects for life. Tidal locking presents another fascinating but daunting aspect of Proxima B's environment, with one side permanently bathed in starlight and the other shrouded in darkness. The planet would experience extreme temperature gradients between the two hemispheres. Proxima B possesses an atmosphere. It could help redistribute heat around the planet, potentially creating a temperate terminator line, the region between night and day that might support life. Without such an atmosphere, though, surface would likely be split between a blisteringly hot day side and a frigid, frozen night side, both largely inhospitable. Understanding how such a world functions climatically is central to determining its habitability and offers insights into the variety of environments life might adapt to elsewhere in the galaxy. Moreover, Proxima B's significance extends beyond itself. It serves as a stepping stone in the broader study of exoplanets and planetary systems, with over 5,000 exoplanets discovered to date, ranging from massive gas giants to rocky, Earth-like bodies. Astronomers are now piecing together the extraordinary diversity of planetary systems throughout the galaxy. Super-Earths, planets larger than Earth but smaller than Neptune, and many Neptunes add to the cosmic menagerie and challenge existing theories of planet formation and system evolution. In this wider context, Proxima B is remarkable for its Earth-like size and habitable zone location, characteristics that are rare and make it a focal point for future study. From a technological standpoint, Proxima B has become a symbol of the future of human exploration. While still unreachable with current propulsion methods, the growing interest in interstellar travel has prompted a reevaluation of space exploration priorities. Projects like Breakthrough Starshot are not only visionary but increasingly necessary as humanity looks beyond Earth for survival and discovery. As climate change, population growth, and resource depletion challenge our planet sustainability, the possibility of finding or even creating a second home becomes more than science fiction. The implications of finding life or the potential for life on Proxima B are profound. Even the detection of microbial organisms would revolutionize biology, philosophy and our understanding of life's prevalence in the cosmos. It would confirm that Earth is not unique and that life may be a common outcome in the universe under the right conditions. Such a revelation would provoke new questions. How common are habitable worlds? How frequently does life emerge? Could there be advanced civilizations elsewhere? The inquiries lie at the heart of exoplanet research and astrobiology, fields that have gained unprecedented momentum with tools like the James Webb Space Telescope. Ultimately, Proxima B is far more than a scientific target. It is a symbol of human curiosity, resilience, and ambition. Its study is reshaping our conception of the universe and our potential future among the stars. Whether this distant planet harbors life or stands barren under a red sun, continues to inspire dreams, fuel innovation, and urge us onward in our exploration of the unknown. As interest in Proxima B continues to surge, so too does the level of scientific scrutiny it receives. Observatories across the world and in space are coordinating efforts to monitor the Proxima Centauri system across multiple wavelengths, visible, ultraviolet, infrared, and radio, hoping to detect subtle variations or anomalies that could point to atmospheric processes or surface phenomena. One of the most promising avenues of study is transmission spectroscopy, where light from the host star is filtered through the exoplanet's atmosphere during a transit. Though Proxima B's orbital orientation doesn't necessarily guarantee observable transits from Earth, any similar opportunities in the future would provide an unparalleled window into the molecular makeup of its fed. Even without direct transit data, the planet's thermal emission and reflected light offer astronomers indirect clues. Scientists are also simulating Proxima B's climate using powerful computer models, inputting different atmospheric compositions, pressure levels, and circulation patterns to predict surface conditions. These models suggest that even with tidal locking, a dense enough atmosphere with a right mix of greenhouse gases could distribute heat evenly enough to create stable zones where life might. Some simulations even indicate that ocean currents, if liquid water exists, could further help to mitigate temperature extremes between the planet's permanent day and night sides. In parallel, astronomers are pushing for more precise measurements of Proxima B's mass and radius, which would allow for a better estimate of its density and internal composition. If the planet is denser than Earth, it may have a large iron core, which in turn might produce a magnetic field through a dynamo effect, a crucial factor for shielding the surface from harmful stellar radiation. Conversely, a lower density might imply a thick atmosphere or an abundance of lighter elements, which could create entirely different surface conditions. Every bit of information matters, and the pursuit of answers has become a multidisciplinary effort involving astrophysicists, planetary scientists, chemists, and even biologists who are working to understand how life might survive or evolve on such an alien world. The study of extreophiles on Earth, such as microbes living near hydrothermal vents or within Antarctic ice, has expanded our understanding of life's resilience, making the possibility of life on Proxima B more than mere speculation. The star system itself also continues to reveal unexpected complexity. In addition to Proxima B and the more distant Proxima Centauri C, astronomers have found hints of a possible third planet in the system, a candidate known as Proxima D, smaller and even closer to the star than Proxima B. This third object, confirmed, could help scientists better understand the architecture and dynamical interactions of the system. The discovery of multiple planets orbiting the closest star to the Sun only reinforces the notion that planets are likely to be common in our galaxy, and that our solar system may not be as unique as once thought. The systems like Proxima Centauri are teeming with rocky planets. It vastly increases the number of potential habitats in the cosmos. Yet, while scientific instruments peer deeper into the universe, another kind of exploration is occurring in the minds of thinkers, dreamers, and visionaries. Proxima B has transcended the boundaries of pure science and entered the realm of cultural imagination. It appears in science fiction novels, films, and artwork, often depicted as humanity's first destination among the stars. The shared fascination reflects our innate longing to know what lies beyond the confines of Earth and to find companionship, biological or otherwise, in the vast, lonely darkness of space. The idea that there might be another world orbiting a faint star just a few light years away, a place with sky, rocks, maybe water and winds, is profoundly moving. It reminds us that exploration is not only a technical endeavor, but also a deeply human one, driven by hope, fear, wonder, and the eternal question, are we alone? From a philosophical perspective, Proxima B forces us to re-examine some of the assumptions we've held about life and its potential.